Before we get started, are there any questions before I start talking at you?
Sir, yesterday you talked about array.toString, and I forget the exact name of what you had to import, but there's an import to be able to access it.
Oh, okay. I'll in the course of the class today, I'll show that. Thanks for bringing that up.
Okay. My follow-up question was, I was just wondering, is there a way in either NetBeans or Java to be able to like access that import to see what the different methods are and what they would return?
Oh, absolutely. There are actually several ways of doing it. One is that you may have noticed that a lot of times um, when you're typing a reference to something, there'll be kind of a pop-up that'll list a bunch of stuff. Have you noticed that?
Yes, sir.
Yeah, yeah. So that uh, if I have a reference to uh, an object, then the NetBeans will, if I put my cursor in the right place, or actually if I think there's if I put it in the right place and hit Control Space, then it will give a pop-up of all the possible methods that I could invoke for that. That's one method. The other method, and if I can remember, I'll show this, is that you can right-click on the name of the class itself, and that can be from the import statement or even where it's being declared in the code. If you right-click on that, and I think you can navigate to the source, and if it has access to the source code for that, it will take you there. Even if it doesn't have access to the source code, it will at least show you what the methods are. And the final method is to use the Java doc. In other words, for all of the Java classes, there is a Java doc, and if and NetBeans doesn't always, in principle, NetBeans should let you see it. If you right click on it and say something like, I believe it's show Java doc, it will take you to that sometimes. When Oracle kind of offloaded the NetBeans to Apache, some things were not necessarily working exactly the same way. Uh, Nevertheless, online, all the Java doc for all of the Java classes are available online if you just do a search for it. So if I have a particular class and I do a search for that class and make sure I say Java as well sometimes, then it will typically come up with uh, a URL for the Java doc for that. And remember, we talked about what the Java doc is. And the Java doc lists every method that is available. And it also lists, things like the the instance variables and stuff like that.
Thank you, sir.
So you said if you hover over the class, it'll it'll show you all the methods.
It is not so much a hover. I'll show what it is when I do the demonstration.
So I had a question.
Yes.
Um, so I found myself getting lost, um, like having to use the getter methods and stuff. So inside those methods, could we create a variable such as um, retrieved, like variable retrieve deck equals get my cards? That because what I'd have to do is like get my cards, dot, what dot 0 or dot whatever place I am in that array, and then dot get value. And so you just get this really long string of using the getter methods. Can we just assign that to a variable that's easier for us to understand?
I think I'm not 100% sure I'm understanding what you're saying. If you have a getter method that returns an array, then that return can be used like any array. So, for example, if I want to know the length, and all I have is access to get my cards, I can just say get my cards.length. If I want to access the specific
I guess for that example right there, could we create a variable just called like hand length or deck length?
well, why?
Just like, again, I found myself like when I try to access like one specific part of the card, I just have this huge run on of getter methods, and
You shouldn't have to do that.
okay.
That accessing one particular element of my cards is one call, and one call only. You shouldn't need to do any of that. So just, if you look through the class hierarchy there, I mean, there are only 2 classes there. You should see a method that will return a particular element of the array. Just use that method. I mean, that in the original card deck, that's what that method was for. If I want to actually get a reference to the card at a particular index, then there's a method to do that in card deck. And so all I need to do is call that method. Does that, are you getting that?
I think so. Yeah, I might have been doing it wrong, but
Yeah, for not, sometimes there is, you will have to kind of have a sequence of things, and you're right in one sense, is that if you find that for whatever reason you have to do a whole sequence of calls, then in order to make that clear what you're doing, it would be helpful to define a local, extra variables just to kind of lay it out.
here's one specific example. In my for loop, I'm trying to get the length of one player's hand. So I have get players at position I dot get hand dot length.
Well,
we're never supposed to directly access the instance variables, and so I thought we're all supposed to use the getter methods.
There shouldn't be any need to do that for the assignment.
That was in my 2 string. Just the way I had it formatted, and yeah.
Yeah, if you formatted the player's 2 string, then you shouldn't have to do any manipulation outside of that. And inside the player has direct access to the array of single cards that's in his hand. In other words, if I just want to print out what the contents of the hand are, which is all that's being asked for here, then if I print a player, then what that should do is simply print the 2 string on that should simply, return the contents of the hand. So outside of the player, there's no need to try to manipulate or even access necessarily what the hand is. Now, I mean, you can I think there was a getter for that, but that's not really necessary.
I might just need to see an example, sir. Like I made one 2-string in the dealer class that spits out all the information. I'm not really sure how to use how I'd use the player's 2-string in conjunction with the dealer's 2-string.
Well, it would be in a similar way as with the card deck's 2-string. In other words, the card deck's 2-string didn't kind of have to worry about what the value or the suit of each of their individual cards in the array was. It just grabbed it from the corresponding 2-string method of the single card. And likewise, the dealer in its 2-string just needs to use the 2-string of each player.
So is that depending on what type your instance variable is? Whenever you call 2-string, it'll use the 2-string of the class it was instantiated from. So I guess like
You say call 2-string. I mean, you invoke a method by object, an instance method by object.method. So if I invoke the 2-string of, say, a single card instance, then it will call the 2-string of single card. If I invoke the 2-string of a player, it will invoke the 2-string of that player object. And if I invoke the 2-string of the dealer, it'll invoke the 2-string of that dealer object.
that makes sense.
You don't just sort of call 2-string. You have to invoke it on a specific object.
That makes sense. Thank you.
Okay. Okay, so now let's see, where are we here? Okay, yeah. So today I'm going to talk about some things that the book sometimes uses sort of object-oriented, like many sort of computing / technical things. They like to use fancy language. So today the two words are composition and inheritance. We've talked about inheritance. Composition is actually really a fancy term for using instance variables that are objects. So and actually what we were just saying about the 2-string in a way is kind of how composition is being used. So composition, it's you don't have to kind of memorize the term. You should know what an instance variable is, and you should know the difference between an object and a primitive. But for example, remember I had a pet, my pets example, and I had an array of pets. Did I do that example? If I didn't, then I kind of ignore that bullet. But card deck, okay, we're talking about card deck. It uses an array of single card, and it also has one of these random things generator. Actually, the generator, the random instance variable in card deck is actually a slightly better example of composition. So, I mean, why call it composition? Well, because there is this class called random. And what does random do? Random generates these pseudo-random variables that we used in shuffling the card deck. The reason it's called composition is what I like to call it sometimes, it's the programmer virtue of that's not my job. So whenever possible, or, you know, it's a subclass of the programmer virtue of laziness. In other words, for the card deck, one of the tasks was, okay, we have this array of cards. When we instantiate it, just like a fresh deck, it comes with all the cards in a specific order, ace through king, for in through the suits. But when we're actually sort of playing, we want to shuffle them. So how do you shuffle them? Well, if we didn't have composition, then inside the card deck class, we would have to implement some means of generating this random stuff. And composition says we don't have to do that. We can be the laziness, or the not, that's not my job principle, says, okay, here's a class called random that we happen to know about because we've read through all of the Java docs. So we happen to know about this random class. And so instead of implementing all that random stuff in card deck, we simply instantiate one of these random objects, and we'll call it generator. And then anytime we want to generate a random index, in this case, an index between 0 and 51, we'll just use one of the methods that's in this random object. So that's, again, it's a fancy term, but that illustrates what composition is about. In other words, composition allows us to be, well, lazy. And again, this kind of laziness is a virtue. And one of the principles, just in general, is that the optimal number of times to implement any bit of logic is 1. Why? Well, one is the laziness thing. It's like, having done it, why do it again? But actually, more to the point on that, if you have code that performs a particular task and you've verified that code, you know that it works, then anything you do to anytime you want to re-implement that, you can only make it worse. In other words, if I were to try to reproduce the logic in random inside of card deck, because what I wanted to shuffle the cards, I needed to generate these random indices. And so, yeah, there are standard ways of doing that. So I could look that up and put all that code into card deck. It would be actually, well, I don't know how, but depending on how fancy you want to get, it could be a lot of code or it could be a little bit of code. But the main thing is that I have a class, random, that already does it perfectly, or at least perfectly as far as I'm concerned. It's actually, it's not 100% perfect, but that's a topic for next quarter. The point is for these purposes, it's good enough. It works fine. So any attempt of mine to reinvent that wheel is just going to make things worse in this context. So, and in this sort of card thing that we've built up, and if we had the whole quarter to devote just to that, we could sort of expand it to where we're actually sort of playing, playing games. We could, we could have poker, we could have Texas Hold'em, we could play bridge, we could play gin, we could, if we had time, we could kind of do all that stuff. Once you finish this particular version of the card thing, we're going to be done with the cards for a while. So some of you may be relieved at that. But the point is that in building them up, the example so far, kind of culminating with the exercise which is due today, is an example of composition. So for example, the dealer uses an instance of poker deck to work with its cards. If it didn't have that, then all the code that you had both in the card deck and in the poker deck would have to be put inside the dealer if you wanted to have a dealer that would shuffle cards and deal out poker hands. All of that code would have to be put into dealer. And but why? So the point is that it's been done, so you have this poker deck class, and so an instance of that will be able to deal out cards, and if I just say, okay, give me a poker hand, it'll just do all 5 cards for me and hand it to me in an array.
So I got a question on that. We had some discussions last night on whether the dealer should be a subclass of poker deck.
Okay, well,
I think we went back and forth, and I think we've come to the conclusion you can make it function both ways, but you're kind of the way your directions, after somebody kindly helped me read through them again, it does sound like we should make it a subclass.
okay, there are two things with regard to that. One is the specification in the handout did not say that the dealer was a subclass of poker deck. So the most superficial answer is that the specification, the design document, did not say that. Okay, so that's sort of the super. So to go a little bit deeper, think of what we're modeling. So the dealer is going to be some guy. So is this guy? Remember the is a relationship. If I'm a subclass of something, then I have an is a relationship with them. So a poker deck is a card deck.
Yeah, I get that, and that's why I was confused. Like talking.
So if you apply that terminology, and it doesn't make sense, then that's an indication that it shouldn't be. In other words, is a dealer a card deck?
Can I just read this to
Yeah, but answer my question first. Is a dealer a card deck?
No, it's not. And that was kind of what confused me. And I think what kind of caused the discussion was the sentence, to reuse the card deck class and add functionality, you'll utilize Java's inheritance, parentheses, subclassing capability. And I don't know if that's just because we don't fully understand inheritance and subclassing.
Okay, yeah. So I see. So the wording was probably not as clear as I had intended. So yeah. So what it really is doing. So a dealer is not a card deck. So the short answer is no. Do not subclass card deck.
Can we get some grace in our grading then, because we have a lot of stuff to do right now, and I think about maybe half of us did it that way because of the instructions. Or I'll have to go back and redo our code, or redo some of our code this afternoon.
Yeah, no, redo it, because that will I don't want to reinforce things that are not good practices. So if that causes extra confusion, I mean, what I can do is I can certainly be looser with the due date on that. So if you need a little bit of extra time, I can be good with that. And if I'll have to look at the wording on that, and I apologize for the confusion. So if there was confusion that suggested that the dealer should be a subclass of one of those things, then that was certainly not the intent, and I apologize for the confusion. But the bottom line is that whenever, whenever you're kind of doing this, the ISA test is a good place to start.
Sir, it's John Morse. Just to clarify in my mind, when you say it's not a subclass, that means we don't use like super dot poker deck.
Well, you would never say super dot poker deck anyway in any circumstance, but dealer is not, should not be a subclass of poker deck. Dealer should just be, should not subclass, should only subclass object, which it does by default. So in fact, neither dealer nor player should subclass anything.
I think I have it.
Okay, yeah. So, and fixing that should just be a matter of if you have, say, dealer extends poker deck, just delete extends poker deck. You'll probably get a sea of red squigglies. And for each of those red squigglies, replace those with a reference to the instance of poker deck. See, because that's what we're talking about here, the composition. So the composition says that, and the key word there is uses. So as opposed to ISA. So a poker deck is a card deck because it's a special kind of card deck. In fact, remember with the pets. So we had this generic pet, and then we had dogs and cats and canaries and whatever. So is a dog a pet? Is a cat a pet? Again, the names are, so if it kind of doesn't make sense that way for well-named classes, then it shouldn't be that way. Composition has the, think of the word uses. So does a dealer use a poker deck? And there you see how that kind of makes sense. Does a card deck use a random thing to shuffle? And so it uses that. A card deck uses an array of single cards, why to figure out where the cards are. A player uses an array of single cards because that's what's in their hand. Okay, so it's really, composition is what's going on there. And in fact, just as a general principle, while both inheritance and composition are important, in my experience, composition turns out to be a more useful concept than inheritance. Again, they're both important, but the reason why you have all these different classes is that it allows you to write fairly small classes that do just a small set of tasks. And just as a design principle, that turns out to be very effective. If you think of how PCs are organized these days. Back in the day, like when personal computers first came out, actually the first ones were these little kits that you had to solder together. But the first computers were monolithic. They had the whole bloody thing. But then as time went on, they became componentized, so that you had specialized pieces. So you had hard drives, and you had like the motherboard, of course, was kind of a fairly big thing. But then you had graphics cards and all these other pieces. And what that allowed you to do is that allowed manufacturers to specialize in making one kind of thing. So companies like Seagate and Western and some others would concentrate on just making hard drives, and they would become kick-ass hard drives, but they weren't trying to make a whole bunch of other things. What that allowed you to do is, if you're putting together you know, a PC, you can then kind of pick and choose from these different components and then assemble them together. And that's kind of how this software idea in object-oriented programming works more, you know, to a certain extent. In other words, if you take a step back from this whole card thing, you know, starting with these, a single card did one thing. It held a suit and a value. That was it. The card deck, again, it did a couple of things, but only a couple of things. It kind of kept this array. It had this random thing that would shuffle them, and then it would kind of just dole them out or deal them, as the case may be. And then the poker deck was able to use all that stuff without having to add anything new except what it needed. And all it needed was the idea of just handing them out 5 at a time and then reshuffling when necessary. So when you look at the amount of code in the poker deck and what it does a lot, because by inheritance, it was able to use everything that was in card deck. That's one of the reasons why inheritance is very useful. And composition is useful because now if I'm a dealer, I don't have to implement all of that stuff that was done in the card deck and keeping track of those, shuffling them. And in poker deck, poker deck will just kind of hand me out cards 5 at a time. And so now if I'm a dealer and I have a bunch of these players and I want to deal the cards out to them, I can just go down and buzz through the players, and for each player, grab the next hand from my poker deck and hand it to the player. So that's, you know, if I had to redo all of that code in the dealer, that would be you know, that would be a whole messy thing. Whereas in fact, it's actually a very small amount of code if I'm doing that. Okay, so that, I mean, that's, you know, composition and inheritance. So again, those are the two main building, well, not building blocks, but ways of building these things. Okay, now I wanted to talk about, okay, now remember, every object has to be instantiated somewhere, or initialized or instantiate. So when an instance variable that's an object is just defined, it has a default value of null. So somewhere it has to be initialized. So where can you do that? Now you can do that in the declaration, and that is something that that should be avoided. So it's something that you're allowed to do, but it's something that is, if you do that, then I'm going to kind of ding you a little bit. Again, so it's legal Java, and it's not a good practice. And these are object instance variables. Static variables are a different story. Static variables a lot of times are instantiated at the time they're declared, but we're not talking about that. We're talking about instance variables. Okay, the best place that I found is, just as a rule of thumb, is in the constructor, and we've seen examples of that. So there are two ways to do it in the constructor. One is that it just is instantiated. So if you think of the card deck instantiated its array of single cards, and it instantiated its random object called generator. That was instantiated in the constructor. The other possibility is to pass it into the constructor. And that's what was done actually in the single card. In the single card, the suit, which was an object, a string is an object. So the suit was passed into the constructor and then simply assigned to the instance variable. So the default place to do that should be in the constructor. And that's 80 to 90% of the time. Now, there's another thing that, another approach, which is becoming less important as computers get more and more powerful. But this is actually something called lazy instantiation. And that is, instead of instantiating your objects immediately, like in the constructor, wait until they're needed. And again, that's occasionally useful. It's again, just for completeness, we'll list it here. And instance initialization. Basically, that's just another one to avoid. So just focus on these two, and mostly on this one.
So I got a question, some vocabulary here.
Yeah.
And I think there's just, I don't know if anybody else has the issue. So instantiate and initialize, is that synonymous?
Yes, in the context here, this should have said instantiate.
Okay, and then, so when we instantiate it, that's like,
Well, yeah, actually, okay, I'm sorry, let me back off from that a little bit. When I say initialize, meaning that at some point it needs to be set. Again, think of the single card. In single card, we passed in the suit that we wanted it to be. So we initialized it. We didn't instantiate it in the constructor. We initialized it by assigning it. So the two ways to initialize are in the constructor are to instantiate it in the constructor or to pass it into the constructor and then assign it. So yeah, so initialize is actually the right word here. So the difference is that instantiate is what instantiate means new. So new, if we say new, then that's instantiate. Oh, with the one exception of a string. With a string, if we have a string equal to, you know, something inside the string, then that's the way of instantiating strings. Initializing could include simply assigning. Does that clear it up, hopefully? Yeah, you know, just for instantiate means new. That's just remember that. So that's okay. So inheritance is something we've talked about, but just as a reminder, every class that you write inherits from this class called object. So there's one class in all of Java that does not inherit from something else, and that's this granddaddy class object. That's in Java, and you never, you know, you can't do anything with that. So every class that we write is a subclass of object. And every other class that's in Java is also a subclass of Java. Now, Java only supports single inheritance, which means that every class can have only one immediate superclass. And we've mentioned that before, but it really bears emphasizing. And you know, why emphasize this? Because before Java, there were object-oriented languages like C++, which is still around, that allows multiple inheritance. That is, in these other languages, and you don't have to worry about it because we're not dealing with them, but just know that there are other languages that allow you to have more than one immediate superclass. So so if I had a particular class, it could be a dessert topping and a floor wax. Now, the thing to understand about inheritance is that everything in the superclass exists in the subclass. Everything in the superclass exists in the subclass, but you may not have access to it, direct access. So everything that's public and protected, just for completeness, but we're not going to deal with protected just yet. But all public things, and in this case methods, all public methods of the superclass are available to the subclass. So if I want to just, if I'm a poker deck, for example, if I'm an instance of poker deck, and I want to call a method that is not in poker deck but is in card deck, I don't have to say super. I can just use the I can just call the method. Now this can be a little confusing though. All private instance variables, remember all instance variables must be private. They exist in the subclass, but they're not directly accessible. So for example, the poker deck cannot directly deal with my cards. It cannot reference that at all. But in the poker deck, that array of single cards exists, that is in there. So that's why we have these public getter methods and sometimes setter methods. We haven't dealt much with setter methods, but say getter methods. So all the getter methods in the superclass are available in the subclass without modification. Now we saw examples of overriding where we wanted to use what was in the superclass and then add something. The example on that was in, say, shuffle deck. In poker deck, we wanted to use the superclass shuffle deck, but then we had one more thing we needed to do, which was to set the index. Okay, but this can be a little confusing because even though you cannot directly access these private instance variables in the superclass, they're there. They are there. It's just you can't get at them. You can only get at them with the getter methods. Okay, and we've seen this override thing. You've seen a couple of examples of them.
The question on the last slide, you said they're there, but they exist within the class of the super class. So like your computer is it's not making a copy and putting that in the subclass, is it?
No, there's only one copy of it. But it's there in the superclass. It's there in the subclass. So it's defined in the superclass, but it's there. If I have an instance of the subclass, it is there. It's just that because it's private, I can't directly access it.
So there's for objects, there's a reference in the subclass. So it knows it's there. It's just you can't really see it because it's private.
Exactly. Oops. Okay, so here's the thing to understand is that whenever you invoke a method, so the JVM, the Java Virtual Machine, so this is not the compiler, this is when you're actually running the program, and it encounters a call to a method. So what it does is it says, okay, how does it know what the logic is? Well, that's what was, if I invoke a method, there's code in the method that it starts executing. Where is that code? That code exists in the class where it's actually defined. So when you invoke a method, the virtual machine, it starts with the actual class of the object, not its declared type. And it works up the hierarchy, meaning that, so let's say that I have an instance of poker deck and I call get card with an int. Now poker deck does not define get card. That's defined in the superclass. So, but if I have an instance of PokerDeck, then, and it's trying to execute the method get card, it will look inside PokerDeck and says, does PokerDeck class have get card? In this case, the answer is no, it doesn't. And so it says, well, maybe it's in the superclass. So it goes up to the superclass of PokerDeck, which is card deck, and there it finds it, and then it executes it. And because the get card in card deck has access to my cards, it will return the card at that index. Okay, so, and if, you know, these class hierarchies can get fairly deep, and that's actually not such a great thing, but they can. So you could have subclasses of subclasses of subclasses. And so what will happen is the Java virtual machine, when it tries to execute a method, it will start with the actual class of the object and work its way up until it finds it. And when it finds it, it'll execute it.
So you said Java only supports one superclass, but
One immediate superclass.
one immediate one. So if Java Virtual Machine is gonna go up the chain anyways, and find the method, I guess I just don't see what makes the superclass so special if the machine's gonna search the whole chain anyways for the method.
I'm not sure I understand what the question is.
So you say like if you call a method that's not in your class right now, then it goes to the one above it and checks that, and if it's not there, then it goes to the one above it until it finds it.
Yep. And it's guaranteed to find it because the compiler has let the program run. The compiler will not let the program run if that method doesn't exist. So
you said that the subclass has all the same methods as the superclass, or it has access to everything in the superclass, right?
well, all the public stuff, yes.
But if JVM is going to search all the methods of all the classes above it, then why does it matter that? I just don't understand what makes a superclass special if the machine's going to check all the methods above it anyways.
I'm really having a hard time understanding what you're asking. So let's say here's a class, and here's another, let's say it has two subclasses. And then this one has yet another subclass here. So let's say I have an instance of this guy, and I'm looking for a method, and the method is actually up here. So it says, are you here? No. Okay, I'll go up and check it here. Are you here? No. Are you, and then it'll finally get it here. Even though it will not check this guy.
Okay.
It only goes up the superclass. This is not a superclass of this. So there is only one path. That's what single inheritance does. Single inheritance means there's only one path from this class all the way up to object. One and only one. So in this, you know, and if there are other things over here, it won't check those because these are not superclasses of this guy. Does that make sense now?
That made sense. It helped visualizing it. Thank you.
Yeah. Okay, so if you, okay, so remember overload and taking way too much time here. So, okay, so I promised to give some examples with code, and I see that I'm running out of time. see where we're here. Okay, so the constructor chain, whenever you say new, it goes to that constructor. So if I say new poker deck, it will start in the constructor for poker deck. If I say new card deck, it'll skip that and go right to the constructor for card deck. And again, we've said this before, but it bears repeating. The first executable statement is either a call to super, which is most of the time, or a call to this. And eventually there has to be one call to super. You can't just have calls to this because that just gets you stuck. So eventually the objects constructor gets called. So the supers just keep going up. So again, it's like if this is object, and then here's a subclass, and then here's yet another subclass. If I say new, it says new here, and then super will go up to here. It'll execute the constructor here, and then super will go up eventually to object, and then the whole thing has been instantiated, and then you keep going. So if there's no error in that, and again, there can be errors, as long as there's no error, then once you come back from the objects constructor, you then go all the way back down and basically keep executing. So when the original constructor returns, so here I've said new, then execution returns, and I now have my nice object. So now delegation, okay, so say delegation, you can actually forget that. I'm not going to make you responsible because it's, I think where we are right now, delegation, I mentioned this just because the book mentions it, but it's one of the things that it would actually be really nice if Java supported this concept, but it's not something we're going to really use here. I say it'll kind of come up. It'll come up, but not in a really fancy way, to be honest. So okay, so it's drat. I was not able to get to the code that I promised. So now in terms of the assignment, I mean, I do want to. There is going to be another program for the lab tomorrow that I think you should be able to complete in time. But do you want a little extra time for today's as well? Would that help? Those of you who got confused about the subclassing. Well, what I'm asking you to do tomorrow will not be affected by what's happening today. So I'll let today's deadline slide. So if you don't get it done by the end of today, don't worry about it. But there will be another one tomorrow. So I will be piling on a little bit. Tomorrow's will not depend on anything we do. We're basically, once you finish this one, we're kind of done with cards for a while. So tomorrow's is going to be a completely different one, and it's just a standalone class that we're going to be reusing in a subsequent exercise.
Sir, can tomorrow's assignment be released early, either today or before class tomorrow, just so we can read ahead and come prepared with questions?
Absolutely, yes. I'll post it later this afternoon.
Thank you, sir.